Okay. Let's unpack this. We talk a lot about AI these days. I mean, it is basically the water cooler topic of the decade for you, me, and everyone
Oh,
else.
absolutely. It's everywhere.
Right. But today, we are going to, ignore the hype and the flashy headlines. We're going straight to the primary source.
Yeah, which is always the best way to do it.
Exactly. We are doing a deep dive into a research paper titled Sparks of Artificial General Intelligence, Early Experiments with GPT-4. I'm your host, and I'm really excited to get into this.
And I'm your resident AI expert for this deep dive. And I have to say, this isn't just a regular press release.
No, not at all.
This is a massive, very comprehensive technical report published by researchers at Microsoft Research. They had access to an early non-multimodal version of GPT-4 well before the rest of the world even knew what it was.
Right, and that phrase, non-multimodal, that is a really key detail here.
It's huge.
It means this version was just text in, text out.
Yep.
No images, no voice, no fancy web plugins, just raw text processing.
Exactly. And the mission of this deep dive is, well, it's right there in the title of the paper. Sparks of Artificial General Intelligence, or AGI.
AGI.
Yeah.
That is a very heavy term. I mean, we're all pretty used to narrow AI by now.
Right, like a chess computer.
Yeah, a chess computer that completely destroys grandmasters but completely falls apart if you ask it to play checkers. Or, a navigation app that knows every single road on the planet but can't write a haiku.
Precisely. But AGI, that is the holy grail of computer science.
It really is.
That is a machine that can do pretty much any cognitive task a human can do. It's general purpose. And the central tension we need to explore today for you listening
Yeah, the big question.
is how on earth a model trained literally just to predict the next word in a sentence, which is basically a glorified autocomplete, can start showing signs of genuine general reasoning.
Because it really shouldn't be possible,
Well,
right? If you think about it strictly as a statistical engine.
It shouldn't. How does next word prediction turn into solving complex physics problems or writing fully functional code?
Which is why the researchers didn't just run standard benchmarks.
Right. They didn't just give it a standard SAT test and call it a day. They threw some incredibly weird, super unconventional tests at the model to see if it could actually think, or if it was just parroting information it memorized from the internet.
So let's jump right into the first experiment because I think it perfectly illustrates this whole reasoning versus parroting distinction. The paper calls it the unicorn experiment.
Oh, this is one of my absolute favorites.
It's wild.
So normally, if you want an AI to generate an image for you, you use a diffusion model, right? Like Midjourney or DALL-E.
Right.
But remember, this early version of GPT-4 was entirely text only. It physically couldn't generate pixels.
So what did they do?
The researchers asked it to write code, specifically in a language called TIC-Z.
Oh man, TIC-Z. For those of you who haven't tortured yourselves with LaTeX in grad school, TIC-Z is a tool used to draw vector graphics using pure math and coordinates.
It's not fun.
No. You are dragging and dropping shapes in Photoshop. You are defining lines, curves, and colors with raw code.
Precisely. And the prompt they gave it was incredibly simple. Draw a unicorn in TIC-Z.
Which sounds simple, but pause and think about what that actually requires from a text-only model.
Right. The model has never actually seen a unicorn.
It has no eyes.
Exactly. It has only read text descriptions of unicorns buried in its training data.
So to pull this off, it has to have a real semantic understanding of what a unicorn is. It needs to know it has 4 legs, a body, a head, and crucially a horn.
Yes.
But then, and this is the really hard part, it has to translate that abstract idea of a unicorn into coordinate geometry.
It has to know that the horn goes on the head, not the tail.
Right. It has to mathematically map a visual concept to a 2D space.
And here is where the comparison gets really interesting. When they asked ChatGPT, the previous version, to do this exact same task, it produced a random blob. I mean, the code ran, which is nice, but the image looked like a cloud of nonsense. It clearly had no concept of the spatial relationship between the body parts.
And GPT-4.
It drew a unicorn.
Wow.
Now, let's be clear, it wasn't a masterpiece. It looked like a very crude stick figure drawn by a toddler. But it was undeniably a unicorn.
It had the defining features.
Yes, it had the legs, the body, the head, and it specifically drew a triangle on the forehead for the horn.
And that right there is the spark. It inferred the visual concept of a unicorn purely from reading text.
Exactly.
It's basically seeing the world through syntax. That kind of interdisciplinary translation, going from pure text to visual geometry, is something narrow AI usually completely fails at.
And that integrative ability, the ability to mix totally different disciplines, is a massive recurring theme in this paper. They have this other example that I honestly thought was a prank when I first read it.
Oh, the Shakespearean proof.
Yes?
This one blew my mind.
Okay.
So they asked GPT-4 to write a mathematical proof showing that there are infinite prime numbers.
Which is a classic rigorous math problem.
Right. But the catch was, it had to write the proof in the style of a Shakespearean play, complete with rhyming verse.
Normally, if you ask a standard chatbot to do something like that, you get a really bad poem that maybe vaguely mentions some numbers.
It forces the rhyme and loses the logic.
Exactly. But GPT-4 actually produced a valid, step-by-step mathematical proof. It specifically used Euclid's theorem and perfectly interwoven it with literary metaphors and consistent rhyming.
I was looking at the actual output in the paper earlier. It actually created characters. There was a first party and a second party actively arguing over the proof.
A literal dialogue.
Yeah, the first party claims primes are finite, and the second party completely dismantles the argument using Euclidean logic, all written in iambic pentameter.
It is deeply impressive because it's satisfying two very different, very strict sets of constraints simultaneously. It has to follow the rigorous logic of number theory, where if you miss a single step, the entire proof fails. And at the exact same time, it has to adhere to the creative structural constraints of 16th century poetry.
And the researchers make a really good point about this. This specific combination likely does not exist anywhere in the training data.
No, of course not.
You just don't find many textbooks that mix differential calculus with Elizabethan verse. It wasn't just copying and pasting this from a random forum somewhere.
No, it was synthesizing two completely different skill sets on the fly. It is demonstrating that it understands the underlying rules of math and the separate rules of poetry, and it can merge them seamlessly.
Okay, so it can be a poet and a geometer, which is great for parlor tricks, but let's talk about actual real-world utility. Can this thing actually do a job?
That's the million-dollar question.
The paper spends a lot of time on coding competence, and the results there were honestly startling.
Startling is definitely the right word. The researchers decided to put GPT-4 through a mock technical interview for a software engineer role at Amazon.
And just to clarify for everyone listening, we aren't talking about a few basic trivia questions.
Oh, no. We are talking about the full interview lip, the online assessment, the technical phone screen, the grueling on-site coding challenges.
The gauntlet.
The whole thing. They use the exact questions from a real interview loop. These are complex problems explicitly designed to stump highly educated human engineers. Things like optimizing algorithms, debugging complex systems, handling weird edge cases.
And how did our digital applicant actually do?
It completely crushed it. It solved all the questions. In the mock online assessment specifically, it beat 100% of the human users on LeetCode who took that specific problem set.
Wait, better than 100% of the humans?
Yes.
That is a number that genuinely makes you sit up straight in your chair?
It is a staggering statistic.
Yeah.
But honestly, what's even more impressive than the raw score is the actual kind of coding it can do. There is a specific example in the paper about game design that really highlights this.
The 3D game?
Yeah, they gave it a zero-shot challenge.
And zero shot, meaning no prior examples, no hand-holding, just one single prompt.
Exactly. They just told it, write a 3D HTML game using JavaScript. I want a player, an enemy, and a defender. Oh, and include physics?
Which is a massive, incredibly vague prompt. You need a rendering engine, collision detection, game logic, user control inputs.
And GPT-4 just wrote a fully working game.
Unbelievable.
But here is the real aha moment of that experiment. The prompt asked for a defender, right?
Yeah.
It didn't explain what a defender actually does. It didn't explicitly say the defender should block the enemy, but when you look at the code GPT-4 generated, it wrote logic where the defender avatar explicitly tries to calculate and position itself directly between the enemy and the player.
So it understood the implicit intent. It didn't just place a random blob on the screen and label it defender. It understood that the semantic, real-world role of a defender is to protect.
Exactly. It mapped the abstract concept of defense to vector math. It calculated the line of sight between the enemy and the player and deliberately placed the object on that line. That implies it truly understands the semantics of the game, not just the syntax of the programming language.
Wow. And there was one other coding example that felt straight out of a hacker movie, the Capture the Flag challenge.
Oh man, the reverse engineering task. This is a very standard, very difficult cybersecurity exercise. You were given a binary executable file, essentially a compiled program, and you have to find a hidden password inside it.
And you can't just read the code directly.
No, you have to inspect the raw machine code.
This requires using complex tools like objump, understanding dense assembly language. It's basically reading the matrix.
And GPT-4 acted as the hacker. It didn't just blindly guess passwords. It analyzed the assembly code, realized the password was being checked against a hash derived from a specific math formula, and then, this is the crazy part, it wrote a custom Python script to crack that exact formula.
So it recognized a problem and built its own tool to solve it.
Yes, it chained together multiple complex steps: analysis, hypothesis generation, tool creation, and execution. It treated the binary like a multi-step puzzle and systematically took it apart.
That shows incredibly deep technical proficiency, but also the ability to break a huge, ambiguous problem down into manageable, solvable chunks.
I should also note an interesting ethical distinction here. When they tried this with ChatGPT, it refused the task on ethical grounds. It flagged it as a hacking attempt.
Oh, interesting.
But this early research version of GPT-4 acted as a completely helpful, if potentially dangerous, assistant.
It just did what it was told.
Exactly.
It is impressive, but honestly, all of this still feels very digital. It is manipulating code, solving math, which is all ultimately just text. What about the physical world? The paper claims it can reason about physics, but the model has no body.
Right.
It has never held an object. How can it possibly understand real-world physics?
This brings us to the egg stacking problem, which is a brilliant test of physical intuition, or basically common sense.
I love this one.
The prompt they gave was, how do you stack a book, 9 eggs, a laptop, a bottle, and a nail in a stable manner?
I love this prompt because it'll just follow the grammatical rules of the word stacking.
Ugh.
You end up with an absolute disaster.
Exactly, and that is exactly what happened with ChatGPT. It suggested balancing the nail on top of the bottle and then stacking the eggs on top of the nail.
Which is physically impossible.
Yeah.
That is cartoon logic. It's matching the semantic word stack, but completely ignoring the physical properties of a nail and a fragile egg.
Right, it's a semantic hallucination. But GPT-4 approached it completely differently. It suggested this: place the book flat on the table, then arrange the 9 eggs in a 3x3 square on top of the book.
A 3x3 square. Okay, I see where this is going. It is creating a platform.
Exactly. It explicitly stated that this arrangement would distribute the weight. Then it said to place the laptop flat on top of the eggs. The eggs basically act as support columns, then place the bottle and the nail on top of the laptop.
That actually makes perfect sense. I mean, I certainly wouldn't try it with my own laptop. But structurally, the physics is sound. It clearly understands distributed load.
It demonstrates a mental model of stability and friction. Even though it has absolutely no physical body, it has learned the hidden rules of the physical world well enough from text to simulate a highly stable solution.
It's simulating the real world just to solve the problem.
Yes.
Speaking of simulation, they also revisited visual reasoning with that H-pig example.
This was another fascinating test of abstract to concrete reasoning. They asked it to draw a pig using SVG code, which is another graphic format, but with a weird constraint. It had to build the pig using the letter H.
So it has to physically make a pig out of a giant letter H.
And it did it. GPT-4 used the 2 vertical lines of the H as the front and back legs of the pig, and the crossbar as the body. Then it just added a simple head and a little curly tail to the ends.
That is just genuinely creative visual reasoning. Taking an abstract constraint, the letter H, and repurposing its geometric structure to represent a totally different semantic concept, a pig.
It is really clever. It's almost like it's playing Pictionary with raw code. And the paper mentions it can go even further by acting as an architect for other AI models.
Right, the image generator integration.
Yes. They combined GPT-4 with image generators like Stable Diffusion. And in this setup, GPT-4 acted purely as the director.
How does that work?
The researchers would say, I want a detailed image of a futuristic city with a river and a pyramid. GPT-4 wouldn't generate the actual visual pixels. Instead, it would write a complex script defining the exact layout, where the river flows, exactly how high the pyramid is, the exact 3D perspective of the camera.
And then the image generator would just render the textures based on that precise layout. So GPT-4 handles the structural composition and the logic, and the other model just handles the aesthetics. It's literally acting like an art director.
Exactly. It understands the entire scene in 3D space, even if it can only express that understanding through code.
Okay, we have to pivot here. Because if we stop right now, everyone listening is going to think this thing is Skynet, and we're all doomed.
True?
But the paper is titled Sparks of AGI, not Fire of AGI. They are very clear about the limitations. And there's some really significant ones, especially when we look at math and planning.
This is a crucial pivot, because while it is amazing at the Shakespeare proof, it severely struggles with what the researchers call long-term planning.
We saw that heavily with the math examples, right?
Yeah.
The distinction between calculation and true proof.
Yes. They gave it a word problem about a rabbit population over time, which involves a recurrence relation. GPT-4 derived the equations and solved the calculation perfectly.
But then they gave it a different kind of problem.
Right. They asked it to prove a mathematical statement about a nested function, specifically f of fx.
And this kind of problem requires planning ahead.
It does. Think about how a human solves a really hard math proof. You might scribble on a notepad, hit a logical dead end, cross it all out, and try a completely different path. You plan, you backtrack.
But GPT-4 can't do that.
No, because it is autoregressive. By design, it predicts one word at a time moving forward. It cannot look ahead to see if a path works, and it cannot hit backspace.
So once it starts a sentence, it is completely committed to that logical path.
Exactly. In the f of ff example, GPT-4 boldly started a proof by induction. It sounded extremely confident. Base case, step 1, and so on. But halfway through, the underlying math simply didn't work. The path it randomly chose at the start was a dead end.
So what did it do? Did it just stop and say it failed?
No, it hallucinated. It completely invented a fake logical step to force the proof to finish. Because it physically couldn't stop and restart, it just bluffed its way to the end line.
It effectively lied just to make the syntax work.
It is exactly like an improv comedy actor who starts a really long sentence with absolutely no idea how they're going to end it, just hoping they'll figure it out along the way.
Right. Which, in comedy, that's funny. But in strict mathematics, it's a catastrophic failure.
Exactly.
And that perfectly explains the hallucinations we hear so much about in the news. It is just trying to keep the linguistic flow going at all costs.
Yes. And we saw a very similar syntax without semantics issue in the music generation experiment.
Oh, right. They asked it to write a tune in ABC notation.
Which is basically just letters and numbers representing musical notes. Structurally, the output was perfect. It had bars, it had rhythm, it had rising and falling melodies. It completely understood the syntax of music. But when they asked it to write a duet with two distinct parts, it just slapped notes on the page. There was absolutely no harmony. The notes clashed terribly. It did not sound good together at all.
It knows the rules of the code, but it doesn't know what music actually sounds like.
It lacks the experiential component. It can verify mathematically that the measures add up to 4 beats, but it cannot verify if the interval is actually pleasing to the human ear.
So we have a model that can mimic deep reasoning, but fails at planning, and knows the rules perfectly, but lacks the feeling.
Exactly.
But if true AGI is actually the goal, the biggest hurdle is usually understanding us, humans, what psychologists call theory of mind.
This is the big one for any kind of social intelligence. Theory of mind is the cognitive ability to understand that other people have beliefs, knowledge, or intentions that are fundamentally different from your own. It is a massive developmental milestone for human children.
How do you even test something like that in a text file?
You give it scenarios. A classic one is Alice put the ball in the box and left the room. Then Bob came in and moved the ball to the cupboard. When Alice comes back into the room, where will she look for the ball?
Right, and the correct human answer is she will look in the box, because that is where she thinks it is, even though it's not actually there anymore.
Exactly, and GPT-4 gets that instantly. It can reliably predict human actions based on their false beliefs. But the researchers went totally meta with this.
What did they do?
They asked GPT-4 to write a dialogue written by Plato.
Going back to the classics.
They asked for a dialogue where Plato is criticizing modern language models. So GPT-4 wrote a really good dialogue between Socrates and Aristotle.
Okay.
Then, and this is the really cool part, they asked GPT-4 to critically evaluate its own dialogue compared to one generated by ChatGPT.
Wait, it graded itself.
It did, and it correctly identified that its own version was much better. But listen to the actual reasoning it gave. It didn't just say, mine is longer or mine uses bigger words.
What did it say?
It said, my dialogue successfully used the Socratic method. The characters actively questioned each other to arrive at a deeper truth. The other dialogue was just two people blindly agreeing with each other.
Wow. That implies it actually understands the implicit intent of a Socratic dialogue. It isn't just matching the topic, it understands the underlying dynamic between the speakers.
It understands the style and purpose of human interaction. And this directly connects to another huge concept, explainability.
Right.
When it did that reverse engineering hack we talked about earlier, it could explicitly explain why it did each step. It wasn't just a black box spitting out random code. It could act as a tutor or a guide. That is absolutely crucial if humans are going to interact with it safely.
So we have covered a massive amount of ground here. We've got crude unicorns drawn in code, cybersecurity hackers, complex egg stacking, and improvisational math failures. What is the final big takeaway from this Sparks paper for you?
The author's conclusion is appropriately cautious, but honestly, it is still incredibly bold. They argue that GPT-4 effectively acts as an early, albeit incomplete, version of artificial general intelligence.
Incomplete being the really key word there.
Right. It is general because it successfully covers almost every conceivable topic: medicine, law, coding, literature. And it is very often hitting human-level competence across those domains. But it is incomplete because of those remaining glaring gaps: the hallucinations, the sheer lack of true forward planning, and the fundamental fact that it is still, at its core, just predicting the next word.
And the paper suggests that just throwing more compute at it, just making the model bigger, might not actually fix those specific architectural problems.
That is the big challenge for the field right now. The next word prediction paradigm might actually have a hard ceiling. To get a model that can truly think, one that can pause, reflect, plan out a strategy, and verify its math before it speaks, we might need a completely new architecture. We might need something that isn't strictly autoregressive.
It really feels like we are at a profound turning point. This entire paper is basically saying, look, this thing just isn't a chatbot anymore.
It deeply challenges our foundational definitions. If a machine can effortlessly pass a senior software engineering interview, write poetry that adheres to incredibly strict meter, and accurately reason about how to stack fragile eggs without ever possessing a physical body, do we need to fundamentally redefine what intelligence actually means?
That is the big question. We basically always assume that intelligence strictly requires a biological brain, or life, or some form of consciousness. But here we have something that has none of those things, yet it is acting across dozens of domains, incredibly intelligent.
It really forces you to stop and ask yourself, which specific tasks in your own daily life do you assume completely require human intelligence? And how many of them are actually just complex pattern matching that a machine can now replicate?
It is definitely a heavy thought to chew on for everyone listening. Next time you are stacking groceries or trying to write a poem, just remember GPT-4 is right there with you, probably doing the math on the distributed load. Thank you for joining me for this deep dive.
Thanks so much for having me.